So today I want to talk about multiplying powers with the same base, and that's the most important part here. You can only combine powers with the same base. You can't combine if it doesn't have the same base. It's got to have the same number base or the same variable base. So the numeric expressions, remember that's numbers only, no variables. So the steps with that are to first add the exponents of the powers with the same base. And then the second step is to simply simplify. So an example of numeric expression is when you have something like 3 squared times 3 to the 5th. If you write it all out, 3 squared is 3 times 3, and 3 to the 5th power, you have 1, 2, 3, 4, 5 threes. So if you look, the only thing that's happening is you're multiplying threes. So count how many you have. You've got 1, 2, 3, 4, 5, 6, 7 of them. So your answer is 3 to the 7th power. So now look at your exponents. There's a square, there's a 5th power. Sorry, I got distracted with my kids, so I'm not sure where I was. So hopefully you noticed the exponent of the 2 and the exponent of the 5. How do you go from 2 to 5 to 7? Add them. That's why we're adding the exponents. So now our algebraic expressions, there's a couple steps here. The first step is to multiply any coefficients. Those are the numbers that happen before the variable. Go ahead and multiply those. The associative and the commutative properties let you do that. Second step, add your exponents. And again, it has to be of the powers with the same base. And then finally, simplify. So an example of that, so the rule for that is a to the m, this is what it looks like. A to the m times a to the n. So if you look, you've got your same base of a, and it equals a. That same base is being added with those exponents. So here's some examples. If we have a to the 3rd power, it means a times a times a. And then we're multiplying 4 a's. A times a times a times a. So if you look, they're all a's being multiplied, so just count. How many do you have? You have a to the 7th power. Look at your exponents. 3, 4, and we get an answer of 7. The only way to combine those is 3 plus 4 gives you 7. Now, the second example has the coefficients. So if you look at it, it's 3 times 1, 2, 3, 4. 4 b's. That exponent 4 is only on the b. That exponent 4 is not on your 3. And then we're multiplying that by 7 times, and then we've got 1, 2, 3, 4, 5 b's. So if you look back at your notes, the first step, multiply any coefficients. That's your 3 and that's your 7. That we can multiply, so that's going to give us a 21. And then count your b's. How many do you have? You should see that you have 9 of them. So go back to your exponents. Here's 4, here's 5. How do you get 9? You add the exponents. So the last piece I want to talk about is scientific notation. There's a couple of steps here. Alright, first thing, multiply your first factors. That's the a, and a times 10 to the nth. It's what's being multiplied by 10. So multiply those factors. After those are multiplied, add the exponents, which you've done every single time. The base of 10 is the same, so add your exponents. Then the third step, write the product in scientific notation. Alright? However, you might not be done here. That last step, you've got to check and see if that first factor is between 1 and 10. If it's between 1 and 10, then you're done. You're good. You don't need to do anything. However, If it's over 10, if it's a bigger number than 10, then you need to rewrite it, all right? Rewrite it in scientific notation. We'll be doing example problems like that tomorrow. See you then.